Road and Track, August 1990. First test, NSX. Acura's sensational sports car takes off. Road and Track road test, Acura Nsx, taking on two of the best sports/GT cars in the world. More than 50,000 for a Japanese sports car? From a country that, a scant quarter-century ago, produced exercises in rolling gingerbread that slogged along with modified forklift engines? And from a company that, until recently, specialized in bread-and-butter sedans and zippy little commuter cars? Well, lo and behold, it's here. It's brilliant, it's ferociously fast, and it's exotic. It goes by the name of Acura Nsx, and its fresh, clean sheet design is about to offer other exotic cars a lesson in civility. Given Honda's history, the NSX's creation wasn't unexpected. Honda managed to best rivals Toyota and Nissan by bringing forth its image-building Acura division in 1986, demonstrating it didn't take a backseat to anyone where sophisticated, expensive sedans and coupes were concerned. And technological innovation has always been a Honda strong suit. Take, for instance, the mid-70s Civic CVCC. That acronym stands for Compound Vortex Controlled Combustion, and it allowed the Civic's engine to burn so clean it didn't require a catalytic converter and, consequently, pricier unleaded fuel. And recently, Honda has ascended to the high throne of technology by powering those red and white McLarens to 2 consecutive Constructors' World Championships in Formula One. When Honda decided to produce an exotic sports car, what could be more natural than a car embodying the spirit and philosophy of the Formula One effort? Editor-in-Chief John Dinkle had a chance to drive a first-stage NSX prototype last year, Road and Track, September 1989, but we'd be remiss not to recap some of the more interesting technical details. At the project's initiation in 1984, some basic parameters for the NSX were set. First and foremost was performance on a level equal to or greater than existing high-end sports/GT cars, which required a power-to-weight ratio of approximately 12:1. To achieve the desired handling and response targets, the car would have to weigh less than 3,000 pounds, which necessitated an engine developing at least 250 bhp. The NSX team considered V8 and twin-turbo V6 configurations, but finally settled on a sophisticated, normally aspirated V6 that achieved the desired power, throttle response, and free revving capabilities, all in a package that was lightweight and compact. True to its Formula One inspiration, the engine was to be mounted in the middle of the chassis for agility and favorable weight distribution, not to mention exotic image. Livability was another priority, and the cockpit had to be made as accommodating as more conventional Acura products. This meant a natural seating position, plenty of cabin width, and ample head and legroom. It also meant an effective air conditioning and ventilation system, something rarely found in other exotics. And outward vision was of great concern, especially to give an unrestricted view of the road ahead and avoid blind spots to the rear. When the team added the fuel tank, at 18.5 gallons, enough fuel for a 400-mile range, rear trunk, at 6.5 cubic feet, large enough for 2 golf bags, and an aggressive track, 59.4 inches front, 60.2 inches rear, or roughly that of an L8 Corvette, the exterior dimensions of the car were roughly sized. If a chassis this large was manufactured from steel, the car would greatly exceed the target weight of 3,000 pounds. A lighter chassis material would have to be used, and after examining alternatives such as carbon fiber, fiberglass, and assorted plastics, aluminum was chosen. Lots of it. Aluminum stampings, castings, forgings, and extrusions, in several alloys, compose virtually every structural part of the car. The only notable exception is a steel tube section under the dashboard that supports the steering column. Door sills, structural parts that make a large contribution to a chassis' bending stiffness, are internally webbed aluminum extrusions instead of the usual, less rigid stampings. Body panels, with the exception of injection-molded plastic for the bumper caps, are made up of 3 different aluminum alloys heat-treated to resist minor denting. They're lighter than steel, but also 40% thicker to maintain equivalent strength. Such extensive use of aluminum created some problems. Aluminum is roughly 1/3 the weight of steel. It's also less rigid and considerably more expensive. A Cray supercomputer was used to determine strengths of various structural components through finite element modeling and structural analysis to arrive at an extremely rigid chassis. But first, the software had to be rewritten to incorporate the bending and torsional values of aluminum instead of steel. Sticklers in the NSX team weren't happy with the dull surface appearance of stamped aluminum body panels. The slight roughness wouldn't allow for the fresh finish they'd envisioned. The solution was to specially polish the stamping surfaces of the dies for a smoother panel. Also, to prevent galvanic corrosion wherever dissimilar metals contacted each other, a special non-conductive coating was applied to nuts, bolts, washers, and brackets where appropriate. Fasteners can be reused up to 10 times before significant deterioration of the coating occurs. The team's persistence paid off beautifully, with a structure that tips the scales at just 460 pounds, complete with doors, hood, and deck lids installed. And with its high rigidity, Acura claims it's the most rigid of any exotic car. The suspension design team could concentrate on optimizing the geometry, rather than compensating for a willowy platform. The suspension system is evocative of a Formula race cars, with exquisite forged aluminum, unequal length A-arms that more closely resemble gnarled tree branches than suspension components. In front, an unconventional solution is used to preserve proper geometry and compliance, traits that are difficult to combine. The front pivots of the A-arms are attached to what Acura calls a compliance pivot that twists slightly under vertical bump loads, moving the A-arms backward slightly to maintain the proper amount of steering toe. The result is more precise steering feel. The rest of the suspension comprises coil-over nitrogen-charged shocks with linear rate springs, aluminum uprights, and steel anti-roll bars at both ends. For extra rigidity and precision, the suspension arms are attached to subframes made up of cast and stamped aluminum pieces. Not just any tires could grace the wheel wells of a car of this caliber, so Yokohama was called in early in the design process to produce a tire exclusive to the NSX. The result was the A022, with 205-50ZR15s in front and larger diameter 225-50ZR16s in the rear. Smaller front tires allowed roomier footwells and a lower nose for better forward vision. And two different tire designs allowed a bit of final chassis tuning. Tread patterns differ slightly front to rear, and the tread rubber compound is about 10% softer at the back. Wheels are forged alloy, 15 by 6.5 inch front, 16 by 8 inch rear, for a savings of 13 pounds compared with similar size cast alloy wheels. These days, anti-lock brakes are almost a given with a car of this class, image and technical content of the NSX. Less expected is traction control. And Honda engineers wouldn't be satisfied with a system that functioned merely as a low-speed traction-enhancing device. No, Honda wanted a performance system that would minimize rear wheel spin over a wide range of speeds and cornering situations. That's exactly what the NSX's TCS, traction control system, does, using the ABS wheel speed sensors to detect rotational differences between the two front wheels. This information is combined with data on vehicle speed and steering wheel angle to determine the yaw rate and cornering force acting on the car. If the computer determines that the surface is slippery, the amount of fuel delivered to the engine is decreased, which reduces engine power and suppresses wheel spin. For those drivers who want to think for themselves, TCS can be disengaged by a switch on the instrument panel. At the heart of any exotic is its engine, that special set of well-orchestrated whirring parts that turn controlled explosions into forceful acceleration while making soul-stirring sounds. Despite its 3-liter size, the NSX's 90-degree DOHC 4-valve V6 is a remarkable performer, with an output of 270 bhp at 7,100 rpm when mated to the 5-speed transmission, and torque of 200 foot-pounds at 5,300. This figures to a specific output that may be just the highest for any normally aspirated reciprocating production car engine, 90.7 bhp per liter, which bests engines like the Chevrolet Corvette ZR1s, 66.3, Porsche 911 Carrera 2s, 68.5, Ferrari Testarossas, 76.9, Oldsmobile Quad 4s, 79.2, and Ferrari 348s, 86.9. And the ripping guttural sounds it produces would likely make Ayrton Senna feel right at home. There's no magic to making this kind of power. It's all been done before. Well, at least by Honda. The valve train employs Honda's VTEC system, variable valve timing and lift electronic control system, which was first used on the firm's motorcycle engines in 1983 and more recently in home market versions of the CRX and Integra. Each set of intake and exhaust valves has 3 rocker arms that correspond to 3 camshaft lobes. During low-speed operation, the outer 2 arms and lobes actuate the valves in a conventional manner. As the revs climb to between 5,800 and 6,000 RPM, the third arm, which follows the center cam lobe with higher lift and longer duration, is hydraulically engaged to the outer 2. Both valves are now forced to follow the more aggressive lobe, and the result is 20 more bhp and 500 more revs, by Honda's reckoning. By ours, the system's intervention is imperceptible. There's no interruption of power or surge felt from the middle revs to the glorious 8,000 RPM redline. Deeper within the steel-sleeved aluminum block are more treasures. A fully counterweighted forged steel crank isn't too unusual, but the beautifully crafted titanium connecting rods are extraordinary. Their lightness partially accounts for the dizzying revs this engine can reach. Intake air is handled by a variable volume induction system, with a separate magnesium plenum under the main system. Manifold vacuum opens 6 butterfly valves at approximately 4,800 RPM to create one large chamber, producing an inertia ram tuning effect that increases high-end breathing and horsepower. Fuel delivery is by Honda's own sequential port fuel injection, and the fireworks are lighted by a direct ignition system, with individual coils atop each platinum-tipped plug, triggered by a sensor keyed to one of the belt-driven camshafts. Interestingly, the engine, which is different from the V6 we drove last year, accounts for the one significant dimensional change between the production car and the prototype: a 1.2-inch wheelbase stretch and an increase in overall length from 169.9 to 173.4 inches required for packaging. It's a shame more of the engine isn't visible after swinging open the rear glass and lifting the carpeted engine cover. Take a few steps back to view the entire car in profile, and it's obvious where the engine resides. While designers of other cars talk about the cab-forward look they've tried to achieve, well, let's just say the NSX's engine location forces the issue. There's enough space ahead of the footwells to house the radiator, the battery, mounted extremely low for a favorable center of gravity, the spare tire, master cylinders for brakes and clutch, and that's about it. Any luggage will have to go into the tail-mounted trunk, which, for a mid-engine design, is quite spacious. It'll hold just enough luggage for a weekend jaunt. If some styling aspects remind you of a jet fighter aircraft, it's not accidental, because the NSX team turned to the General Dynamics F-16 Falcon for inspiration. The NSX's tail seems to stretch on forever, an illusion further enhanced by air intake panel creases that start at the leading edges of the doors. The tail culminates in an upward sweep that continues into a full-width rear spoiler. Squint, and that sweep could be a vestige of a fighter's vertical stabilizer. And the NSX's greenhouse, very much an oval when viewed from above, takes on an even more aircraft canopy look with the roof and pillars painted black. The nose looks a bit generic, something hard to avoid when using retractable headlights. The front air intake, which looked overly large when the car premiered at the 1989 Chicago Auto Show, looks much smaller now that the slat dividing it is body color instead of black. Except, of course, when the car's exterior color is black. The overall look is one of aggressiveness and efficiency, and it's truly a case of form following function. The forward cabin allows the driver an uncompromised view of the road, and the long tail and rear wing serve to stabilize the car at high speeds. Low drag was desired. The CX is 0.32, but more important was achieving the balance of drag, lift, and yaw forces for stability in crosswinds. The NSX's forward cabin design results in a satisfying feeling of command. Seating position is extremely low, but the first impression is that you sit high in the car because of the low cowl height and the way the door panels and center console sweep downward, forming separate cockpits for the driver and passenger. Leather-trimmed seats provide proper lumbar and ladder support, but narrow anatomies seem to fit best. The leather-covered 3-spoke steering wheel has a suitably grippy rim, and the airbag in its center has been made smaller through use of a new, thinner, but equally strong bag material. The NSX design team eschewed gimmickry, and as a result, the car has conventional analog gauges set in a Ferrari-like hooded binnacle. Footwells are generous with only slight wheel well intrusion, and overall room is ample in every direction except up. Taller sorts will find their heads close to touching the scooped-out headliner. Enough about technology and aesthetics. What's this young upstart like to drive? Acura invited us out to Laguna Seca Raceway, just inland from Monterey, California, for an afternoon of track time, then turned us loose the next couple of days for open driving around the area. We brought along a Porsche 911 Carrera 2 and a Corvette ZR1 as road-going companions to a red and black NSX 5-speed for a spirited trip through some of California's most beautiful country, on 2 lanes past hill after rolling hill of straw-colored grass studded with pine and Monterey cypress. A lengthy detour would take our trio to the slightly less glamorous place of King City, where the good-hearted management of the city's airport offered up the taxiway for the purpose of instrumented performance testing. In between landings of Cessna 150s and Beechcraft Bonanzas, of course. Finally, as all good things must end, we'd have to give the NSX back. After more than 300 miles over a variety of roads and surfaces, the NSX proved itself in the midst of its peers. With a 0 to 60 sprint of 5.7 seconds and a quarter-mile dash of 14 seconds flat, Honda's Exotic has shown that it deserves a place in that stratospheric performance league of sports/GT cars. Stopping distances are among the shortest we've ever recorded, courtesy of the NSX's 11.1-inch vented disc brakes and 4-channel anti-lock braking. But the way its performance can be so easily tapped in real-world conditions is even more impressive. Of the 3 cars, the NSX has the most confidence-inspiring handling. All that computer time put into suspension geometry was well spent, because there's a feeling during hard cornering of using every square centimeter of tire contact patch to its fullest. Its unassisted rack and pinion steering, power assist is standard on cars with automatic transmissions, is a little heavy at low speeds, but as the pace quickens, its precise and increasingly friction-free feel gives the driver the touch of a surgeon to slice delicately through apexes. When the adhesion limit is reached, the result is mild understeer and a scuffing sound from the front tires. Lifting off the throttle results in the front tires regaining traction, or if you've entered a turn far too quickly, the rear end stepping out a touch, then just as quickly tucking back in again. The Honda traction control system really improves its worth on spirited driving. On the track at Laguna Seca, however, switching off the traction control gives the driver a sense of having more control of the car at its limits. The over-the-edge, can't-bring-it-back feeling of some of the mid-engine exotics is noticeably, and thankfully, missing. Ultimate grip is mighty impressive at 0.93 G, but could be higher. This figure was arrived on at a makeshift skid pad riddled with bumps and pavement seams. We'll retest the car at our normal test site and report the new number in a future issue. The Corvette is a most willing partner in backroad shenanigans, but its middle name isn't Finesse. Big, bad, and brutal, yes, but a ballerina it's not. The Vette fares best on reasonably smooth roads where its mammoth 275mm section front and 315mm rear tires can effectively check the lateral force generated by its 3,500 pounds weight. Under such circumstances, it can generate 0.94 G, the highest figure we've recorded for a production car. Throw in a few bumps and ripples, though, and the ride deteriorates. The chassis shivers, and the suspension starts to feel a little nervous. The Vette's ace in the hole is the feeling of having such huge quantities of rubber on the ground that if it should skitter sideways a tad, resumption of control is only milliseconds away. Handling balance is reassuringly neutral, with increasing oversteer a function of how much the LT5 engine's 370 foot-pound of torque is applied to the rear tires in mid-corner. The Porsche 911 Carrera 2, the ultimate iteration of the rear engine, air-cooled flat-six 911, is a veteran who sipped at the fountain of youth. Wider tires, coil spring suspension all around, careful chassis tuning, and a displacement increase to 3.6 liters have made the Carrera 2 the most docile, powerful normally aspirated 911 to date, and mild understeer now masks the tail-heavy weight distribution that can still make itself known in severe situations. The Porsche's tires give a mite more warning than the other two as cornering loads increase, and even though Porsche's excellent power assist, the steering is able to fight back a little to tell the driver what's happening at the rubber road interface. A little protest of this sort doesn't mean the Porsche is lacking in the lateral acceleration department. It pulls a very respectable 0.85 G in this steady-state cornering contest. Where the NSX really distinguished itself from the Corvette and the 911 was in the course of cruising Highway 101 on the way to King City. The Honda V6, capable of thrilling race car sounds at full or part throttle, hummed silently along with no more clamor than the power plant of a Legend coupe. Its suspension, while not downright supple, was much more livable for long drives than the somewhat more firmly sprung Porsche or the sometimes jarring Corvette. The point is the Corvette tells you you're driving something special through the omnipresent heady thrum of a big V8 and ride quality that never lets you forget the corner you've just taken at 30 miles per hour could just as easily have been done at 60. Likewise with the Porsche, whose mechanical whir might be frightening if it weren't known that the company makes highly successful, reliable endurance racing engines that sound much the same way. We all put up with the 911 interior's endearing anachronisms, like floor-mounted pedals and reflections off the instrument glass because, like it or not, these are the things that give a car flavor and character. The NSX may lack character of this sort, and Honda can't yet hope to match the allure of the status, heritage, and prestige of the well-entrenched exotics, but the NSX is certainly a car possessing few flaws. Technically, it's brilliant. Dynamically, it's outstanding. And its chameleon-like character, that of equally competent, soul-stirring road ripper and comfortable, relaxed, long-distance tourer, has raised the ante markedly in the exotic, high-end sports/GT marketplace.